My name is David Awad. It is a pleasure to meet you. I am joined by my colleague, another developer evangelist at R3 named Irina Tsimoshenko. So Irina will be, Irina will be in the comments answering your questions. If you have anything to leave in the Q&A, you're more than welcome to do that as well. What we're going to be talking about essentially is how to support the trade finance use case with blockchain. So if you're in that vertical, or if you work on those kinds of problems and you're interested in things like atomic swaps and how to introduce electronic contracts that can be shared between parties, that's mostly what we're going to be talking about today, with the exception of a couple of entertaining jokes and nonsense in between. If that sounds interesting to you, then by all means, stick around. All right. So I'm going to jump right into it. What we're describing here, before I get started, my slides have correctly informed me that I do want to remind you about a couple of tools and resources we have available. The usual, the Slack, YouTube, Twitter, GitHub, email, and our free training site. The best way to reach us tends to be, at least right now, on Slack, but you can also reach us over email as well. All that being said, so our goals for today is a brief overview of what Corda is and how the blockchain works in trade finance. We'll talk a little bit about Corda's abstractions. I will introduce you to the concept of a bill of lading and a letter of credit within trade finance, and then we'll do a demo of a revamped letter of credit CorDapp that I've kind of picked up from a past Corda demo that we have revamped for Corda 4.6/4.8. So let's jump into it. So the themes we're thinking about when it comes to trade finance, at least as a company, tend to be things like payments, settlement on ledger, know your customer laws, those kinds of things, know your supplier, negotiable title documents. The big examples of this that we're doing right now, we're doing some experiments with TradeShift. We are doing things with GT Nexus, Bank Trade, and Temenos. We've also done a couple of things with Finastra, Infosys, and we have a couple of other people who are planning to do some really interesting projects with Corda. So if these ideas sound interesting to you, or you are working on such a thing, you're more than welcome to reach out and tell us about it. The really fun ones tend to be things like invoice management, where you can deploy your literal PDF onto a blockchain as part of a transaction, and you can have all of the participants observe, approve, etc. We also have some core banking providers like Temenos, Silver Lake, etc. And there's some other interesting uses like custody transfer, contract management, and commodities management, if you are interested in that kind of thing. So it's being used in a lot of different use cases, as you might expect, because Corda is a pretty generic platform. So our scenario is an electronic bill of lading. The idea here is that right now, trade finance is pretty well understood. The intuitive requirements are things you can probably imagine, right? We want the ability to monitor digital assets. We want to be able to accept and manage derivative assets like debt instruments. And we want the ability for sellers and their banks to communicate with each other to receive letters of credit, letters of purchase, etc. And you also want, and this one's kind of obvious, you need a rock solid infrastructure that's available 24/7. Which software tends to be very good at being. So I'll give you a quick fun fact. Just for a bit of trivia, before we talk about how you might actually manage a contract in the modern world using R3, or rather using Corda and deploying your contracts onto a blockchain, I will leave it as a question for the audience and post your idea in the chat. How do you think that people in the 13th century kept their contracts from being modified? So for example, let's say I'm a 13th century solicitor in the UK and I have written a contract with you. How would we be sure that our contract has not been modified or tainted in any way? Leave it as a question for the audience and let's see what you guys think. How could we be sure that a 13th century lawyer, how could a 13th century lawyer be sure that their contract hasn't been tampered with? Give a third party a copy, not a bad guess. The answer, none of you would ever guess this. It's actually incredible. But let's see what else. Any other ideas? Any other guests? Guests. Any other guesses? How a 13th century lawyer might be sure that their contracts haven't been tampered with. Personal stamps, not a bad guess. Any other ones? Dyes. That's also an interesting idea. It's not custom dyes. A tree with scars. Actually, that it's funny you say that. So there was a notion of using sticks that were marked in particular ways in order to identify who owned a particular asset. What ended up happening with these sticks is that people would store them inside of banks and secure areas. And eventually holding those sticks ended up being called stocks, as we currently refer to them. So not a bad guess, Lazar. Certainly not. But the answer here is actually sheepskin. Lawyers would find sheepskin parchment and use that as an anti-fraud device because the texture of sheepskin made attempts to remove or modify the material very obvious. So because of the way that the fat deposits in the skin would, I guess the word I'm looking for is the way that it would marinate with time made it very difficult to actually modify what was written on the sheets of paper. And so sheepskin was a very safe thing to write a contract on. So if you're curious about that, I will throw a link to that in the chat so you can see that and see it for yourself. Fortunately, we do not have to go bother a bunch of innocent sheep every time we want to deploy a contract, at least not in the modern day. We have smart contracts. So let's talk a little bit about how this actually plays out in the modern world. And hopefully, if any of you are 13th century attorneys, you won't feel too bad about it. So the software stack for our letter of credit, CorDapp, it's going to be a pretty intuitive one. We're going to have Corda nodes for the notary, for two central banks, a product exporter and a product importer. We're going to have a web server, as usual. We're going to have a little website that customers can go to actually step through the transactions that you'd want to. We're going to have a minified version of that I'll show you in a bit. And a fun fact, Bolero is currently doing this with Corda. You can currently get electronic bills of lading with, as a service. So I should have actually given you the literal definition. If you go and Google search bill of lading, what you will find is not the clearest, but a bill of lading is a detailed list of goods in the form of a receipt given by a carrier to the person consigning the goods, which is to say that if I buy something from you, you will publish a bill of lading and give that to me to inform me that my goods have been shipped, at which point you will have been paid before that you issue that bill of lading and ship them. So Bolero is currently a company doing that. They're certainly not the only one, but it's worth being aware of. So before we get into the specifics of that, I just want to outline very quickly the components of a CorDapp. States are the objects themselves that you want to represent on your blockchain. This could be commodities, this could be oil, this could be soybeans, etc., that kind of thing. So states are the objects themselves, the actual item you want to represent. My go-to example for this is cars, but we could represent anything that could fit within a Java class, really, or a JVM compatible language class. Contracts are the actual methods, if you will. Contracts outline what it is that you can do with the objects you're working with. In this case, a contract could outline, let's say, for selling a car has to have a positive non-zero mileage. It has to have, in New Jersey, license plates are 6 characters, so it has to have a 6-character license plate. The VIN number has to correspond properly to the manufacturer of the vehicle, those kinds of things. You can deterministically measure all of these things, and that's the big feature of contracts. They have to be deterministic. And so inside of our contract, we could outline that in a command, such as sale or manufacture of a contract, has to have A, B, or C, and these are really just if statements. If you can validate these things about your contract, then you know that your particular transaction is good. It will go through without any problems. And if it does not, if the proposed ledger update is not valid according to these contract rules, unsurprisingly, the transaction does not happen. It is stopped either at their node or at your node or at the notary. All 3 of them must also all validate the particular ledger update. And we've seen that in the terms of flows. Hopefully all of you have seen this before, but just in case you don't know what a flow is, I will break down this diagram in a little more detail in a minute. But a flow is essentially just the process through which we execute the business logic. So again, if you're looking for a specific example, a state is really just that object, that car. We have the notion of a token state. And within your code, you'll just say state implements contract state, where contract state is the particular Corda abstraction. And once you have that, then you can just define your instance variables for the class. In this case, integer amount, party issuer, party owner. Now, party is a Corda abstraction, but the principle is the same. You're just going to define in your code very simply, here are all of the class attributes or member variables or instance variables that I want to exist for my particular digital asset or object or state. Now, when the nice thing about your states is that all transactions are point to point. The network is permissioned and everything is on a need to know basis. It's not like your classic blockchains. If you're working on something, maybe an ERC20 or another public blockchain, you're not going to have a situation where Demi can find out about state one. That just would never happen. So it's a very different environment why someone would choose to use Corda as opposed to one of the public blockchains. So what we're offering you here is the ability to say Alice wants to communicate with Bob point to point. They can form a transaction and neither Carl, Ed, or Demi would have any idea that this transaction ever occurred. They cannot view what exists in one. They cannot view this state that is stored securely within the vault on the Corda node on the vault of the Corda node on Bob's machine. Similar story with one being stored in the vault of the Corda node on Alice's machine. So I just wanted to clarify that. And then you can imagine the remainder of the relationships as they're kind of pictorially illustrated. So now that you've got your states, the idea of a contract is intuitive enough. One note I want to distinguish as well is that Corda uses the unspent transaction output model for our blockchain transactions, meaning that an input state must be explicitly consumed by the network in order to be modified in a transaction that specifically takes that input as an existing state as input and produces a desired output state as output. So in this case, my selling a car to you must consume a car that has already been introduced onto the blockchain. So in order to sell a car must first be issued. An issuance transaction is a separate thing we'll talk about in a second. But assuming my car exists, then I can have a valid transaction to actually consume that state. I can apply my rules, license plate 6 characters, the car is a certain color, VIN number corresponds to the manufacturer, that kind of thing. If all of those things are valid, then a ledger update is recorded and we actually have an output state. So if all of that makes sense, again, as we described, if one of the rules fails, if any of them fails, it's an and relationship and your contract, or rather transaction update, will not go through. And the last thing to be aware of, issuance transactions. If I create a new car, there are other contract verifications you can apply to these different kinds of operations. Selling is different than making. So when I make a car, I need my mileage to be, maybe the mileage needs to be 0, or maybe it needs to be under 100, that kind of an idea. The issuer is probably going to be a manufacturer, for example, a retail consumer, or a car repair shop probably cannot run a manufacturing transaction or a manufacturer contract command. So it's important to be aware of that distinction here. And so contract code looks very similar to what you might expect, given everything I've just described. So you can, in token contract.java or car contract.java, what have you, you have these things like no inputs, one output, and these would all just be essentially if statements. You can have requires or asserts, however you want to do it, as long as it throws an error, really. So assuming that's all good, now we'll talk about flows. I don't want to get too into the nuances unless anyone has any questions about this. I try to avoid the nuances. Let's take it on faith at least a little bit that this works, and I can refer you to the notary documentation because it tends to be the thing we get a lot of questions on. But assume a simple 3-node network where node A is Alice and node B is Bob. If Alice wants to perform a particular ledger transaction, let's say she wants to perform specifically the manufacture contract command for a car, and she wants Bob, a car dealership, to be aware of it, Alice will propose an update. In this case, she will run a flow that proposes a particular update by creating an output state, adding that to a transaction, and then checking that update herself with her contract verification code. If her contract verification code validates that the particular transaction is good, then her node, her Corda node, will sign the update, publish that out to the required participants. In this case, node B. Bob needs to know that he's about to have a new car that's going to exist, let's say, at his dealership. So Bob is going to run a similar thing. Bob will have a flow that is triggered, called a responding flow, that receives the notification that an update is about to happen, checks the update, and assuming that the contract verification code on his node is also good, and you can have additional logic in the responder flow, but I don't want to get too far in the weeds here. Bob can sign the update, then notifies Alice. If Alice gets back the okay, then the notary pool is notified of this possible transaction, at which point a customizable set of consensus operations are run on the part of the notary, as well as the contract verification, if you wish. Once the notary says things are good, Alice is informed, then Bob is informed, and then we have completed our transaction update. And this scales up quite nicely. I believe Corda Enterprise can do 6,000 transactions per second. So a pretty amazing level of scale that you can get to here. Certainly one that beats out a lot of the limitations we have on the public blockchains. So that's really nice. It's worth being aware of. I'll take a quick break for questions before jumping into how to implement our specific bill of lading or our letter of credit / bill of lading CorDapp. So any questions so far, just before we go a little bit further here? I will take that complete silence as a no. All good? That's good to hear. Okay, great. Well, so now let's leave the blockchain on the table for a minute and brainstorm for ourselves. How do we think this process actually currently works, right? If we're implementing a bill of lading, the real use case here is I want to buy something from you internationally, but we don't trust each other. So what do? Well, like most problems, we have our banks deal with it, right? So what tends to happen is I will create a purchase order from you. I will apply for a letter of credit, meaning I will go to my bank and say, hey, I want you to guarantee to them my purchase because I don't want to be out the money up front. I'm not going to put up the money right off the bat to pay you to send me stuff because I don't trust you. So what I do is I go to my bank and I say, hey, I want to purchase this stuff. I want a letter of credit. The bank says, okay. Then when my bank informs the seller's bank that I have a letter of credit, which means that the bank, my bank, guarantees my payment. So now you, the seller, have a guarantee, not just from me, but from my bank that I will pay out and that the bank will take on or underwrite the risk of sending Buddy and Rocco to my house to get the money for that particular purchase. That being said, now that you have that letter of credit in hand, you have a contract from a bank signifying their intent to underwrite the risk that you would take on as someone who's selling to me. Now you can run with this. Now I will, as the seller can add a bill of lading, give that back to the bank. The bill of lading being a document that signifies that I'm going to ship this stuff. I'm going to put it on a boat. I'm going to send it to you. And setting aside all these weird little nuances like the Uniform Commercial Code and the whatever maritime transport laws you want to apply, we'll set all of that aside. Although we can have that kind of thing encoded in smart contracts, it's worth noting. For example, if you're sending UCC, if you're sending a UCC movable good, you actually could encode contract verifications for that sort of thing. For example, if you live in a jurisdiction that has, I don't know, if you live in a jurisdiction where the seller is responsible for transport, you might have different smart contract verification rules than you would if it was kind of a send it and forget it and buyer assumes the risk. But that tends to vary based on jurisdiction, but it's fun to be aware of those kinds of things. In any event, the buyer adds their bill of lading. The buyer ships their items. And the seller's bank pays the seller. This is important. So the buyer's bank gave a letter of credit and informed the seller's bank and the seller. So the buyer takes this letter, or sorry, the buyer's bank gives this letter to the seller's bank. So the seller's bank now has this guarantee they're going to get paid. So the seller's bank pays the seller when the seller ships. So now the seller is good. Seller's not interested anymore. The remainder of the problem is between these three guys. So now the seller's bank is out, let's say $2 million. So the seller's bank is going to go back to the buyer's bank and say, pay me. And that's exactly what happens. Buyer's bank will pay the seller's bank. But now the buyer's bank has loaned cash, effectively speaking, to the buyer, right? Because the buyer's bank paid up front, even though the buyer did not yet, right? I did not pay anything. I asked my bank to cover me. The bank said, sure, bank covers me. Now I'm out $2 million on credit. So then the bank comes to me and says, hey, pay up. And that's what happens as far as the last step. So that's really the full use case. This is how right now, anyway, at a very high level, of course, we're abstracting a lot here, but in a principled sense, this is what's happening when international trade occurs. It's mediated by banks that enable people to have a lot less risk that they're taking on off the bat, if you will. So if this makes sense to everyone, I'm happy to take a question or two, or we can just jump forward. I will leave it to you to share any questions before I run with this. Give another minute for questions, maybe. If there are no questions, I'll tell a joke. Kind of reminds me of a mortgage guarantee letter. That's a great example. Yeah, exactly. Well said, Emily. Will you use token SDK here? Good question, Lazar. You could certainly represent your bills of lading with a token. We'll actually see. I won't spoil the magic here, but I will actually go through the CorDapp and show you guys what the stakes look like and how they're implemented. So I will leave that to the future, but I don't believe it is used in this, at least. I don't believe this particular. I'm trying to think of whether the older version of this CorDapp did. You could do it either way, though. Open API. Not sure exactly what you mean, Gomafi. Do you mean is the code freely available? And the answer to that is yes. I will give out the source code for this. Yeah, I'll be showing you guys links to the older version. Everything you're going to see here is all open source. So I will give you guys links to the older versions of all of these things I'm about to show you. Any other questions? Going once, going twice. Sweet. All right. So let's do a demo. Hooray. All right. So what you're looking at here is the original version of the letter of credit CorDapp as far as the front end. What we've done is I'm going to demo the original way that this CorDapp functioned as far as the web app, and I've ported forward specifically the CorDapp code in order to show you how it would work on Corda 4.8 or 4.6, etc. There's not a lot of compatibility problems between those two, or between the more recent versions. So we have our workflow here on the left, and this will outline most of what we need to know. So I believe if I click right there, nice. All right. So the first thing I'm going to do is I'm actually going to issue some cash. So if I go to click on First Bank of London, I believe this will get me. Where am I going here? I just need to issue myself some cash. There we go. So I have a cash issuance CorDapp. And so here I have a little table that lets me issue cash to a particular person. Now in this case, our CorDapp contains, and I should have specified this, our CorDapp contains a couple of people on this map. We have First Bank of London, we have Analog Importers, Shenzhen State Bank, and EMEA Exporters. So EMEA Exporters is here, and they are going to be our exporters. Analog is going to be our importers. Nothing too surprising there. So let's see how this plays out. we're going to give analog importers some cash. They're going to purchase something from Lookma exporters, and it will be managed and mediated by these two banks. So that will get us there, assuming I can get back to cash issuance. So I'm going to do a quick transfer. Now our bank, in this case, oh my gosh, I misclicked, guys. I'm sorry. There we go. So our bank has some money in a couple of different coins. First Bank of London. So we're going to transfer to, interesting. Good news, everyone. My live demo seems to be doing strange things. Huh. Let me try a quick thing here. Maybe I can kick this from the other side. Unfortunately, this is going to take a quick second. Arena just gave me the heads up that this is currently a little too small. So let me do a couple things. Is that more visible for people? Hopefully. So what I'm going to do, I'm currently rerunning this because it looks like for whatever reason, a couple of the pieces of data got blown away. But I left this process running overnight, so it's possible that's why. We'll see if we get lucky and we can get through it. Probably won't be a big deal, but we'll keep our fingers crossed. So Gomatha, you said you had a question about insurance. Not exactly sure what you mean. Oh, maybe you're asking about cash issuance. So I was issuing cash to myself from First Bank of London to analog importers. That's this guy. Once this thing is up, there we go. Great, looks like we've made it. So I'm going to click here. This should let us do that. Wipe out all these nodes. Awesome. I'm going to do some cash issuance for myself. There we go. That's what I was looking for. That 10 million in USD coin. Now, I wasn't expecting to have to zoom in this much, so this looks a little bit clunky, but let's just run with it. So I'm going to transfer to a recipient. I'm going to transfer myself, analog importers, rather. I'm going to transfer analog importers. I'm going to give them 3 million bucks in the currency of USD coin. Simple, stable coin. I'm going to go submit, and it's going. Great. So what I've just done is an issuance transaction, specific type of flow, and we'll see the flows underlying all of these things. So now First Bank of London only has 7 million bucks, but our analog importers have what they need. So now we're going to just kind of step through the process here. So the buyer is going to create a purchase order. And what's going to happen here, our analog importers has a balance of 3 million, which is quite nice. So I'm going to go up here. I may need to zoom out a little bit. There we go. Hopefully this is still legible. So I'm going to auto-complete most of the details here. So let's say I'm going to purchase 679,000 objects. In this case, they're going to be OLED 6-inch screens for smartphones. So we're going to get those from Shenzhen. And so I drop in the name of the seller. I'm going to create my purchase order. So there is my purchase order. And so that goes to their bank and to them. So now that I made this purchase order, I need to apply for a letter of credit, as we described, right? If I'm going to buy anything successfully, I'm going to need to apply for a letter of credit in order for my bank to be willing to underwrite this purchase and the risk that they're about to take on. So I'm going to go apply for a letter of credit. So in this case, I'm going to auto-complete one more time just to make things simple. So the issuing bank is going to be that First Bank of London, right? And the advising bank is going to be the Shenzhen State Bank. And for the value of, let's say, 1.3 million USD. Simple enough. And we're hoping that that goes to the Maritime Center in Liverpool in the UK. I go to apply. So that comes from First Bank of London to me specifically. Very nice. Letter of credit comes through. Great. Now that that's the case, the buyer's bank has to accept this. All I've done is apply for the letter of credit. So I'm going to just approve it. Simple enough. So what you're seeing now that I've approved the letter of credit, now the actual transaction can happen. Now these guys can ship their stuff. And so what happens is the seller, now that they've seen this, they're going to add a bill of lading and they're going to ship. So there we are. Now that this has been issued, the seller can go create a bill of lading. So we'll do that first. We're not going to ship our stuff without telling people we're shipping. So we have a bunch of details, consignor details, etc., our product. So I'm going to go and submit this information. We're going to add a bill of lading. And then we will ship. So we will confirm that we have shipped these things. There's our beautiful boat animation. And now that we've shipped it, you can see that we can update the states of these things. And we'll talk a little bit more about how this happens. But just for the sake of getting through this without spending too much time, believe me that these things are working the way we expect. So now that we've shipped it, we're now on the other side of the majority of the complexity here. It's now no longer the seller's problem. Seller's bank has to pay them, right? So that's not super surprising. It should pop up right here. Amazing. So we can actually view the bill of lading as the seller's bank, which is beautiful. We see here a couple of things that are really nice as far as what Corda can provide us. Transaction hash. Again, this is stored on the blockchain, completely immutable. If I, as the seller's bank, wanted to manipulate this, I couldn't. It's all, it is all immutable. And so we have the signatures of the different parties involved in that transaction. In this case, the actual exporters who, of course, created the bill of lading and shipped, and the notary pool. And we've got those transaction IDs. So anyone who wanted to could also look into those. So now we're going to pay the seller because we are now legally obligated to. So there's that cash that flies over from point A to point B. Beautiful. So now we've paid them and beneficiary has been paid. Our status has been switched. So now the buyer's bank has to pay the seller's bank. And so now, of course, because it says beneficiary paid, we have to go pay the seller's bank so that that status changes one more time. So now the First Bank of London pays Shenzhen State Bank, and this, there we go, the advisory bank has been paid. So now we have one last piece of the puzzle, which is that now the bank, the First Bank of London is out $1.3 million. So the First Bank of London probably needs to go and do something about this. So in this case, the seller's bank, excuse me, not the seller's bank, the buyer's bank, the buyer must pay their own bank back. So here we are, buyer, analog importers, seller, Lokma, or Lukma. And then because the advisory has been paid, we just have to sell this ourselves. And we can also look at the bill of lading, ensure that things look the way we expect. But you'll notice that we have a little more information here, which is quite nice. First Bank of London is now on there in the signatures. So I'm going to go to settle. And that basically means that the buyer is going to pay the buyer's bank. So you see that here with the buyer, the red bubble paying the pink, or at least the pins on the map as far as they are concerned. And now we have the issuer paid. And so we are done. We have gone through the entire workflow, or the entire flow of how this can be done entirely immutably on a blockchain. It is a beautiful thing. And so I have a question from Lazar about the flow diagram. Shouldn't the notary verify before the parties to sign? Yes. Well, oh, I see what you're asking about. Sorry. It depends. So I don't think you actually need to be worried too much about the order of operations, as long as all three of those parties actually do all agree to the transaction and validate it. You won't get burned by the specific order in which it happens. But in most Corda flows, the notary is the last one to sign a transaction. But without the notary's signature, the transaction never goes through. So now that we've gotten through that piece of the puzzle and we've done our demo, I'm going to show you guys the code. And we're going to talk a little bit about what this looks like. So I've got my letter of credit revamped. So unsurprisingly, there's a lot of code that goes into this, but not a ridiculous amount. The reason for this is because we need flows to do all of the different pieces of this puzzle, right? So we're going to need flows for creating our bill of lading, creating a purchase order, going to the bank and issuing cash. We did that first. So we issued cash, created a purchase order. We need to apply for a letter of credit. We need to approve the letter of credit. We need to we need to create a bill of lading. We need the seller's bank to pay the seller. We need the buyer's bank to pay the seller's bank, and we need the buyer's bank or the buyer to repay their bank. So it will not surprise you that we have flows for all of these things. We have one for the advisory bank to get paid, for the buyer to apply for a letter of credit, for the buyer's bank to approve the letter of credit, creating the bill of lading, etc. These flows are going to be what we need to do all of those things. On the other side, of course, as far as the states, the objects themselves, we have bill of lading states, letter of credit states, purchase order states, and application states. On the contract side, we have the same thing: purchase order contracts, letter of credit application contracts, and bill of lading contracts. So these contracts define what we can do with all these objects. Now, I'm not going to painstakingly sit here and walk you through every single one of these, but I will look through a couple to see if we can just get the ideas down pat. So we talked earlier about how states are the objects themselves. If you're not much of a programmer, I apologize. This may be a little bit painful to watch, but hopefully it won't be too bad. So we can just start with the purchase order state. This is the first thing that happens. A purchase order state belongs to the purchase order contract, not surprising. We have a data class called purchase order state. It has a couple of things: an owner, a seller. We have a Boolean called consumable. We have the properties. These are just purchase order properties. We don't have to worry too much about that, but if you're curious, that comes from the imports. We have the participants. Now, participants are going to be important, as well as this notion of linear state. So I'll talk a little bit about these. So the participants to your transaction. Earlier, when we looked at that flow diagram, we had Alice and Bob. Those were the required participants. In this case, there are only two participants: the owner of the purchase order and the seller. In this case, right, I'm informing the seller that I want to purchase something. And so that's what we have here. And of course, this is a linear state. Now, this is a Corda abstraction that says that this state evolves with time. And so I want to be able to use a linear ID to refer to this particular state, so that when my transaction happens, anyone on any node that was involved, right, point to point, any node that was involved in this transaction can then use this linear ID and query for this particular transaction. And that is a very nice feature to have. You don't always need to have that for your states, of course, but it can be very convenient. You can make all kinds of queries and build some additional features on top of that. So the purchase order properties are defined here. They are things like the purchase order ID, the seller, the buyer, the purchase order date, and things like goods and terms, and the pay date. So if this all makes sense to you and this feels intuitive, then the rest of them will feel really intuitive as well. So we'll go and look at a couple of other ones, but without the same level of detail. We have the same thing here with the letter of credit application state. Here, there's much more people involved. There's the applicant, the issuer, the beneficiary, the advising bank. And again, these are all parties. Those are Corda abstractions. The properties, these are just defined here. Things like the type of credit, the port loading, the port discharge. These were those large forms we were looking at earlier that fortunately we auto-filled. So our letter of credit application properties look relatively reasonable. And again, this one is also a linear state. We want to be able to refer to this later. We want, after we've created the letter of application state, to be able to modify it later in a flow. And last but not least, I'll show you the bill of lading state. Similar story here. Linear state has the parties involved. They're explicitly defined: owner, seller, buyer, advisory bank, issuing bank, timestamp, some properties, and an ID, and the participants. Great. Now, how do we run with this? Let's go look at the purchase order contract and see if we can start to map some of these ideas together and stitch them up. Our purchase order contract. We said that a contract defines what we can do with a particular object, in this case, a state. Now, in our state code, we explicitly say this purchase order contract must be associated with this state. We say it belongs to the contract. All that being said, if we look back here, it's not going to be particularly complicated. If we look at the commands, there's 3 types of commands. This is probably pretty intuitive now that we're breaking this down. What can I do with a purchase order contract? In real life, this is a sheet of paper. I could maybe issue it. I could write this contract, suggest it to the buyer, suggest it to the parties involved, get everyone to sign it. And then I could also probably fix it in time, meaning I can say this contract is no longer modifiable. Now, in traditional contract law, that happens when all of the, well, technically speaking, it depends on whether it's a common law contract or what have you. But let's say, in at least for convenience, generally, once all of the parties have clearly manifested or outwardly manifested their will to contract such that a reasonable person would think that they were intending to go into an agreement, then the contract is considered locked. In the case of our smart contract, we have a command to lock it manually for the purposes of enforcement on the blockchain. And of course, the ability to extinguish it. This kind of makes sense. So I can give you a contract, we can sign it, and we can burn it. Okay, so we know what the commands are. We know what the contract is called. So now verification. We don't have too much for verification here, but you can start to see how powerful this can be when we look through this. So verify. Verify is the method that literally verifies the validity of a command that we're running. So let's look at a couple of things that happen inside here. The first thing we're going to actually do is we're going to look and see what kind of command are we looking at. So for example, an issuance command is this code block. These are all of the verifications that happen when we are issuing a new contract. Now that is separate from locking the contract, and those are separate from extinguishing it. So these are different validations we can apply based on what exists in the actual contract verification, or what the transaction is that is trying to be initiated by the flow. And we'll look at that later. So let's say we're issuing, just for the sake of really bringing this home. Well, an issuance transaction has what? No input states, one output. There has to be only one, literally one output state of a specific type. That has to be a purchase order state. And so we do that here, right? Now, what else do we have? During issuance of the purchase order, if we had no one output purchase order should be included in the transaction. The number of output states included was transaction.outputs.size. So we have our first error message. We can throw illegal argument exceptions and give clear, distinct error messages for what the problems are in the transactions we receive, right? And we can do that for all kinds of different other possibilities. For example, here we have a require that, where we specify what else needs to be the case. What else is true about our issue command? Well, 1, there's one input state. 2, the transaction is signed by the purchase order owner. In that case, of course, if I'm going to give you a contract, I have to sign it. The seller and buyer must be different. That's an unfortunate typo. But here we look and we're like, okay, is the buyer name different from the seller name? It should be. If it's not, that's weird. I can't sign a contract with myself. I can't, the purchase order ID must not be blank. I have to have an ID for this contract. It has to be unique. So a lot of these kind of logistical errors from human error with contracts go right out the window, because we can apply all of that kind of foundational logic right into the contract. The term must be a positive number. Again, not super surprising. The date must be in the future. And the goods associated have to be with the purchase order themselves. And so you can see that here. These are just conditionals, just if statements. They're just making sure of basic facts about this contract, but we can do a whole lot more. For example, you could say, if the goods are 6-inch OLED screens, then the following must be true. They must have a particular voltage. They must have a particular safety rating. They must have a particular water resistance. You could look at all of these different kinds of things, and you could use oracles during your contract verification to introduce off-ledger data. For example, if you have a smart contract for trading stocks, you could use an oracle to retrieve the stock price at a given time, so that you can be sure that you're not buying something for a drastically different price outside of the bid-ask spread. Another random example. So is all of this making sense so far? I'll take another second to drink some water and see if anyone has any questions. If this is intuitive, and hopefully people are starting to see where the power of this can come in. Emily says, makes sense. Could you explain party again? Sure. So conventionally, let's say you are going to run Corda, right? So Emily, we sit down at a computer, we install Corda, we run a Corda node, and you say to the world, this is Emily's Corda node, and I am going to be available for transactions. So what you would do if you actually wanted to share, let's say, a Corda network with me, and we wanted to exchange a bill of lading, what we would do is we would compile this CorDapp. We'd install it on your Corda node and on my Corda node. It's just a jar file. You can copy it onto the machine. Once you have it, you are a party. You are a particular individual entity that will sign transactions. So the idea here was that one Corda node corresponded to one entity or individual in the real world. So that's what you're seeing there. A party is just a member of the transaction. Now, this gets a little trickier when we think about when we think about the accounts SDK and the ability to have multiple accounts on one Corda node. But for simplicity here, think of a single Corda node mapping to a single entity, kind of the same way that a single wallet on a cryptocurrency maps to a single wallet can only be used as itself. You cannot have a transaction on behalf of a wallet from somewhere else. It has to be that particular wallet's private key that signs and consents to a transaction. So parties here are things like the owner, the seller, and what's happening mechanically underneath there is that a party is really just a collection of a little bit of data on top of a private and public key. That private and public key is being exchanged between the nodes. You can see a little bit more about that in the Corda source code, and I'll give you a link to that later on, but it's certainly outside the scope of what we're doing now. Cool. All right. Glad to hear that makes sense. Awesome. So we've talked a little bit about the purchase order contract. I don't want to go through a whole bunch of contracts and show you guys, not that contracts are not wonderful and very fun to write, but I'll show you guys a little bit more just to drive this point home for a minute here, and we'll see where we're going. Letter of credit application. Now the contract commands here are probably going to make sense. I can apply, they can be approved. Show us the most complicated flow pair. Oh, I don't know if you want that, Lazar, but we'll see. I can show you guys. I will be showing you guys a couple of flows in a minute here. So our letter of credit application is also pretty intuitive. There are two types of commands. I can apply or approve one. And so that's what's happening here. And the verify is actually pretty simple. I've left a couple of these commented out. The original app did not implement too many contract verifications. But you can see, I'll leave it as an exercise for the viewer to add some verifications for these, but you can now intuit what they are, which is the most powerful part of this. Now the bill of lading contract. This is probably going to be the more complicated one. You can see that a little bit. Now we've left some to-dos in there if you're interested in taking a look, but as far as our demonstrating this concept, we have two commands, to issue and to transfer. Makes sense. I can issue a bill of lading and I want to transfer it over to the other party so that they know that they're going to receive stuff. And so the input state should be a contract state. The input should be a bill of lading. The output should be a letter of credit. The outputs and inputs, you can put all kinds of specific verifications on top of them. And then in our issue, when the command is an issue command, we have a series of requirements we can apply. One input state. Input state's a letter of credit. Two output states. Output is a bill of lading. Other output is a letter of credit. Owner of the bill of lading must be the beneficiary. Input letter of credit has a status of issued. Output letter of credit has a status of laded. You can see where this goes. This can be very, very powerful. As we add more and more of these contract verifications, we get more and more certainty that the state of the world is what we expect based on what we publish onto the blockchain. That's where it gets really nice. So with that, we have flows finally. So I will show you guys a couple. The first one that we ran was to create a purchase order flow. If you're curious about the cash issuance flow, we can take a look at that too, but it's pretty intuitive. Creating a purchase order. All right. So most flows are actually going to be pretty intuitive here. We don't have a super complicated flow pair, but let's look for a minute here and see if we can't find something that's interesting. Now, what is it that's happening when we're running a flow? We said that flows were the ability to initiate a transaction between A and B. So if A and B are running a transaction, what's happening? Well, based on what we were talking about with Emily, we know, let's say that I and Emily have two Corda nodes. A and B are going to talk to each other. We don't know how we don't need to know how it works, but we know that these computers are going to talk to each other magically through the ether, through the magic dragon that is the internet. The packets are going to get sent from A to B, and the packets are going to be sent back from B to A. So what happens here is, in order to initiate that process, I go onto node A and I say, run my transaction. In this case, create purchase order flow. When I run create purchase order flow, this is what is invoked. I must pass a couple of specific parameters to the flow. Those are going to be, if I'm creating a purchase order, I have to specify the seller, and I have to specify purchase order properties. That probably is not surprising to you, because this is exactly what we would need and what we supplied when we created our purchase order originally. So what happens here is I actually go to the specific Corda node that's going to initiate this purchase order flow. In this case, that's mine. If I'm buying something from you, I have to initiate the flow. I have to provide this data to my own Corda node. What we do here is we define something called a progress tracker. When you actually run these transactions, you'll see a really nice little series of checkboxes. You can get some nice IO and some logging features by using the progress tracker, but it's not required. But you'll notice here that there's a couple of things here: finalizing transaction, signing it. So the function call, or the call method, is the crucial one here. We start by setting the progress tracker. We're getting the notary, so we do that here. This is just going to the Corda service hub and getting a reference to the notary so that we can pass it as a signer to the transaction. We then get the transaction, so we get the identity of the seller. We get that by identity service, parties from name, seller name, and we get single or null. So we get a reference to the seller. If we can't find them, we throw an exception. We do a similar thing. We now create a purchase order state that's going to have our identity, which is just a reference to the Corda node that's running this flow. Then we get the seller that we just referred to. When we ran the flow, we passed the seller's name. So that's how this comes from. That's where this comes from. Then we pass the purchase order properties that we also got in the flow. And we also specify consumable true. The issue command. The command is purchase order contracts.commands.issue. It's not surprising. We looked at our contract and we said one of the things we can do with a purchase order contract is we can issue it. I can give you the contract so we can sign it. Now I pass our identity.owning key as another argument to the command constructor. We'll set ourselves away from why we do that for now. We're going to create something called a transaction builder. A transaction builder does exactly that. It builds a transaction. We can add an output state to our transaction, right? We were talking about how in the unspent transaction output model, we supply inputs to our transactions or outputs to our transactions. And inputs must explicitly be consumed. In this case, there's only an output state. So this is an issuance transaction. And now we're adding the command. We created the command right here. So we're telling Corda, I want this purchase order to be the output state. I want this command to be added to it. And I want the notary to be specified so that I know who's going to notarize. Thank you, Tommy. Glad to have you. Yes, I will give you I have the code in the slides, but if you like, if you're on Slack, you can send me a message at David Awad and I'll get you the links or the slide, whatever you need. So thank you very much, Tommy. So the last thing we'll do here, we'll set our progress tracker's current step. Here we have the sign transaction, sign initial transaction flow. We pass the builder, meaning we're taking the transaction builder and specifically signing it ourselves from this Corda node. And then we can initiate the flow with the seller and then pass that output to the finality flow. And the finality flow is just a subflow. It's a subroutine you can use that makes it easier for you to collect the signatures of the other parties involved. And that's what happens. I've left a comment here for an interesting tidbit. It used to be that you didn't actually need to provide the initiation with the other nodes. It used to be that you could actually just call finality flow raw. You still can, but technically this is deprecated because it's not super safe to do, but it's an interesting tidbit to be aware of and think about in terms of what is secure. Is it safe for you to sign a transaction without knowing anyone else is on board? And the answer is not really, but it's still not super dangerous to do, at least within Corda, but it is deprecated for a reason. So Lazar, to answer your question, the double spend is checked kind of in a couple ways. Technically speaking, it happens here in finality flow. When finality flow happens, it is literally finalizing the transaction. So finality flow does a lot of the work of communicating with the other nodes, collecting the signatures, and then ensuring that they are good, if that makes sense. When you said specify a notary, is that like a bank or a legislative notary on the blockchain? So the notary is operated either by your network operator, or if you're doing it yourself, the holder of the notary does have a lot of power. It's important to be aware of that. With permissioned blockchains, there are certain trade-offs you're making. Now, the notary can be anyone. In theory, everyone could be running their own notaries. You could randomly select them. In this case, our notary was simply selected by getting literally the first notary we could find, right? We call network map cache.notary identities, but you could have a pool of notaries. You could have 30, 40, 50, 2,000. It doesn't really matter. So if you wanted to, there's a couple different ways to do it. You could have everyone run their own notaries, and then within the CorDapp code, agree that you're going to randomly select one, so that you have kind of a pseudo proof of stake happening with the notary selection. But generally speaking, it's most convenient to just get the first identity of a notary. You usually won't run into any issues, but it's up to you and your Corda network configuration how your notary will exist. I want to be respectful of everyone's time, so I'll just make sure that these links are specified if you are interested in any of these things. Oh, whoops! I put in the wrong link here. This should say letter of credit web, but that's okay. I will get that to you. The source code of the revamped letter of credit CorDapp that you saw here is available on my personal GitHub if you are interested. Lazar asks, I have mastering Corda. Is there any other which you recommend? Funny you mentioned that, Lazar. I'm actually doing a one-off interview with live questions with Jamil, the author of that book. I'm going to be doing that in I think it is going to be April 19th, but we haven't announced it yet. So if you're interested to come and throw some questions at Jamil, that would be a good time to do so if you're curious about mastering Corda. But off the top of my head, there's not a lot of other books that I recommend other than the typical ones. Take a look at the Bitcoin white paper for seeing the actual invention of the blockchain, no Poisson distributions, those kinds of things, and the theoretical math and number theory that go into it. I also think zero knowledge proofs are very interesting to know, so I recommend taking a look at those. We do a little bit of zero knowledge proof type of math in Corda and other products like Conclave, if you're familiar with that. If not, go check it out. But those are worth being aware of. And so that is all that I have. If anyone has any other questions, I am happy to answer them. Feel free to share. Otherwise, we can call it a day. Going once. Here we are. What can you say about self-sovereign identity in Corda? I'm not sure I've heard that phrase before. Maybe I know what you're talking about, but I'm not sure what self-sovereign identity is. So I'm sorry about that, Lazar. Maybe I should know. I might be dropping the ball really hard right now. For the nodes in Corda, are those private nodes? Yes, exactly. So Emily, to answer your question, the idea here is that it's a permissioned blockchain, meaning when I have a transaction with you in the classic public blockchain model, the way that consensus is achieved is by every single node. When I have a transaction with you, I broadcast it to the whole world because it's impossible for a majority or a plurality of the world to deliberately come to a false version of events. So that's the idea. In Corda, because we have a private blockchain that's members only, if you will, I'm not broadcasting my transactions to the world, but we have a complex mix of trade-offs we're making. So with Corda, we're deploying our nodes individually and then hooking them all up to each other. Awesome. Thank you very much, Lazar. I appreciate it. All right, well, if that's the case, I think we are all good as far as I can tell. Unless anyone else has any other questions, we can call it here. Arena, we can probably stop recording. So thank you for that. See if we can, oh no.